Hi everyone, welcome back to our channel. Today we are going to solve problem number 31. This is obtain the inverse Laplace transform f of s for the given f of s. We need to find out the f of t for the given problem. Okay, so let us try to see here how to find f of t. Here we are having three roots, so I can write down this f of s as I'm assuming one constant as k naught. K naught divided by s plus 1 whole cube plus k1 divided by s plus 1 whole square plus k2 divided by s plus 1. Okay, and the next left term is k3 divided by s. So this is the f of s given to us. This f of s is s minus 2 divided by s into s plus 1 whole cube. So when you see this equation, the LCM terms are s into s plus 1 whole cube. Okay, so here if you see this LCM, this you are going to get s into k naught. Okay, so here you will be getting k1 into s into s plus 1. Okay, so s square s cube will cancel, you'll get s plus 1. So plus k2 into s plus 1 and s plus 1 will cancel, then you're going to get s plus 1 whole square, and k3 into s will get cancelled, then you'll get s plus 1 whole cube. Let us try to expand it and write down the terms. So this denominator and this denominator will cancel, and in the numerator we are having only s minus 2. Therefore, s minus 2 is equal to s into k naught. Okay, plus k1 of s square plus s. This is the first term we are having, plus k2 into s into s a plus b whole square. You can write it as s square plus 1 plus 2 into s is the one term. Okay, plus a3 into a plus b whole square. You can write down s cube plus 1 plus 3ab into a plus b. Okay, so this we can expand. So this we can further expand as s cube plus 1 plus 3 s square plus 3s. Okay, multiplied with k3, plus when you expand this, you are going to get s cube plus s plus 2s square is the another term. When you come here, this is k1 s square plus k1 s, and first term is s into k naught plus. Now let us try to expand each individual term, all the s cube. So ultimately we are going to get s into k naught plus k1 s square plus k1 s plus k2 s cube plus k2 s plus 2 s square k2 plus k3 s cube plus k3 plus 3 s square k3 plus 3s into k3. So now let us try to take the common terms. Here we have only s minus 1. So this is s to the power 1. So first let us try to take S3 coefficients and compare only S3 coefficient. Here there is no S3 coefficient, 0 is equal to, this is one S3 coefficient, this is another S3 coefficient. So I can write down it as 2s square plus, sorry, so S3 coefficient, no, S3 coefficient means you will be getting 0 is equal to k2 plus k3. This is one term. Next one is s square coefficient. S square coefficient is, this is one term, this is another term, this is another term. Okay, only s squares. Therefore, you are going to get from here s square 0 is the s square coefficient in left hand side. In the right hand side, you are going to have k1, and here you are going to have 2 into k2, and here you are going to have 3 into k3. Okay, so this will be the second equation. Okay, so now s to the power 1 coefficient compare in right hand side as well as in left hand side. So s power 1, what is the coefficient here? We have only 1. 1 is equal to, okay, s power 1. When you compare, this is one term, this is second term, this is third term, this is fourth term. Okay, so then we are going to get the star marks you write down. So s power 0 k naught plus k1 plus k2 plus 3k3. Okay, so this will be the ultimate equation 3. Similarly, compare s to the power 0 coefficients. S to the power 0 means nothing we are having here. S to the power 0 means 1. Okay, that is minus 2 is equal to, what is the coefficient? Only we have s to the power 0. This is only the term. Therefore, k3 is equal to minus 2. So we got k3 is equal to minus 2. Substitute the value of k3 here. So 0 is equal to k2 minus 2. Therefore, k2 is equal to 2, the second answer. Okay, so substitute the values of k3 and k2 here. So 0 is equal to k1 plus 2 into k2. K2 value is 2 plus 3 into k3. K3 value is minus 2 here. So from here, if you solve, 0 is equal to k1 plus 4 minus 6, k1 minus 2 is equal to 0. Therefore, k1 is equal to 2. So this is the third unknown. Okay. So similarly, you substitute this all this in this value, then you will get the value of k naught is equal to 3. So now substitute all these values in this coefficient, then we can write down the equation. Okay. So if you substitute here all in this equation, then we can write down f of s after partial fractions as f of s is equal to k naught. K naught value is 3 divided by s plus 1 whole cube plus, what is k1 value? K1 value is 2 divided by s plus 1 whole square is the another term, plus k2. K2 value is 2 divided by s plus 1 plus k3 value is minus 2 divided by s. Okay, so like this we will be getting 4 terms after partial fractions. Okay, so for this we need to apply inverse Laplace transform. Already we know that Laplace of t to the power n e to the power minus at is equal to n factorial divided by s to the power n plus 1. So here, when you compare here, so here, uh, I mean, if you take t equal to n equal to 2 here, so this is t square e to the power minus a is how much? 1, that is equal to 2 factorial divided by s cube. So here s cube is there, but in the numerator we require 2. So that's why what I am going to do here is f of s I am going to write down it as 3 into 2 divided by 2 into 1 by s plus 1 whole cube is the first term. And the second term I am writing it as 2 into 1 by s plus 1 whole square plus 2 into 1 by s plus 1. Next one minus 2 by s. For this, let us try to apply inverse Laplace transform. So inverse Laplace transform if you perform, this is f of t, that is equal to, so in the numerator we require 2 and here you will be getting 3 by 2 and this is 2 factorial by s cube. We can write down this as e to the power minus t into t square plus 2 into, how to write down, 1 by, so if you take n is equal to 1, so this we are going to get when n is equal to 1, we have only one term here. So t to the power 1 e to the power minus t, which is nothing but 1 divided by s square. Okay. Therefore, you can write down this as 2t e to the power minus t. So 2 Laplace, Laplace of e to the power minus at, you are going to get 1 by s plus a. So for this, if you apply inverse Laplace transform, then this is e to the power minus at. So for this, if you apply e to the power minus t, so Laplace of constant is nothing but 1 by s, and for this if you apply inverse Laplace, this is 1. So minus 2 into L inverse of 1 by s is nothing but how much? 2 into 1. That's how we are getting the ultimate equation of f of t for a given function f of s by partial fractions method. So hope you are able to understand. This is in the form s plus a. Here a is how much? 1. Therefore you got e to the power minus 1. So here it is 2 by s cube. 2 by s cube you can write on it as t square into e to the power minus t. So this is the format of writing a given function f of s in terms of f of t. Hope you are able to understand. If you feel my explanation is good, please give a strong like to the video, and those who are watching studying the same subject, share with your friends. And if you are watching the channel for the first time, subscribe to my channel with the name KV Tulasiram for more unsolved problems. So if you have any doubt, you can ask your doubt in comment section, and if you are having more doubts, you can ask and I can answer your doubts. Thank you for watching the video. Yours obediently Ram. We'll meet in the next video.